Hi everyone, this is lesson 7. The topic is climate change. We'll talk about global warming and how the climate has been changing globally. So, what is the main concern? All over the world, global land and ocean temperatures have been increasing over the last 100 years. So, this graph here shows the temperature change in anomaly. So, from the average, whether temperature has gone up or gone down. So as you can see, these are based on observations, all based on stations and measurements. So since 1880 up to present, we've had about 1 degree Celsius change in the global average temperature. And that's concerning because we're talking about globally an average temperature change of 1 degree Celsius, which means that various regions could have locally have had more increase in their average temperature. Um, this figure here shows the global temperature change, basically the same data but spatially. So the more orange, yellow, and red you're looking at, more warming. And as you can see in this plot, things have been warming since the early 1900s, but it's not up until the 1970s and 80s when things really started taking the turn for worse. So we've seen a lot of the warming since 1970s and 80s up until present time. We've seen most of the warming of that 1 degree Celsius over the last 40 years. So here we are in 1950s, so I'm going to speed this up a little bit. So 1971, 72, we start seeing more orange, yellow, and red. Um, as you can see, the Arctic region, the colder regions are warming more here. So the 1990s, we see much more reddish area over this higher latitudes. Since 2000, we've had the 10 most warmest years since 2000. So we see that there's been more warming here. Globally, there's more red, orange, and yellow. So again, we'll talk about what this means when you change this global temperature. But what's the cause of all of this temperature change? Now, carbon dioxide is the major greenhouse gas that's behind this global temperature change. Currently, the concentration is 406 parts per million. This is a global concentration, but you can see even since 2006, the, uh, the, the carbon dioxide parts per million has been increasing steadily. So it was about last year, 2 years ago, we exceeded this 400 parts per million threshold. Um, this year shows the carbon dioxide concentration going back to up to 400,000 years from present. So here we are, zero means today present, 400,000 years is before present. So as you can see, carbon dioxide has been going down and up and down and up. Basically, this relates to the ice age, and when you have high carbon dioxide concentration, we are coming out of an ice age. When the carbon dioxide concentration is low, it's an ice age. So you see that there's an ice age and an interglacial stage and ice age. Um, and we see that over the last 400,000 years and even up to million years, carbon dioxide has never gone beyond 300 parts per million, right? So as you can see this line here, that's 300 parts per million. What we see now is carbon dioxide is currently about 400 parts per million, which is where we are right now. So this is something that we haven't seen in almost a million years. So this is based on ice core data. This is carbon dioxide that has been taken out from ice cores, and this is basically unparalleled to any situation over the last several million years. So that's very concerning that instead of going towards an ice age, here we are where the carbon dioxide concentrations are just off the charts. Now, this is in Hawaii, a place called Mauna Loa, where carbon dioxide has been measured steadily since 1960s. So here you can see the measurements. The red is the carbon dioxide concentration. It goes up and down, mostly because when the plants are in full bloom, they utilize a lot of carbon dioxide, but when the plants shed their leaves, the carbon dioxide isn't used. So you see a cycle, but this black line shows the trend. So it's been increasing. Now, if you look at global concentration again, so March 2017, we were at 406 parts per million here. Um, so again, there's a lot of data here for the global concentration here. Uh, if you look at the full record here, this is the full record. Uh, So again, there's lots of data here that shows how the carbon dioxide has been measured and has been changing. But the more important part is that carbon dioxide has never been above this 300 parts per million threshold, and this is why it's very concerning. So what's the main reason? Uh, the main reason is something called a greenhouse effect. Um, so here is our solar energy balance. So the sun is the primary thing that drives everything here on Earth. Most of the incoming energy, uh, some of it is basically intercepted by clouds and atmosphere and reflected back to space. About 48% is absorbed by land and oceans. The energy that's taken in by land and ocean, it actually, the Earth re-radiates that heat uh, into this long wave energy. Now, long wave energy is actually intercepted by clouds, and it's actually sort of sent back to Earth. So here, this energy is actually trapped, uh, and that's called the greenhouse effect. So this long wave radiation that's going back to the space, that's re-radiated from the Earth, is actually trapped by greenhouse gases in the atmosphere. Gases like carbon dioxide, water vapor, methane, and it's actually sent back to Earth. So the more we have these greenhouse gases, the more heat is being trapped here. So this is a visualization of how the greenhouse gas affects. You can think that this is a carbon dioxide molecule, and when the long wave radiation hits this, it kind of excites it and it's sending it back to Earth. Now we have a ton of carbon dioxide sources here. All of these red arrows are indications of carbon dioxide sources. The green arrows are sinks, which is where carbon dioxide is taken in. So again, the only places that carbon dioxide is taken in is in the oceans. Carbon dioxide dissolves. Plants, vegetation use carbon dioxide for photosynthesis. So as you can see this green arrow here. But most cases we see that there's lots of sources. Fossil fuel is a big source of carbon dioxide. Agricultural burning, volcanic activity can also spew a lot of carbon dioxide. So again, we have a ton of human-induced anthropogenic sources of carbon dioxide. And as I see, this is again the similar plot that I saw earlier, where we look at the carbon dioxide concentration going back to up to 600,000 in this plot. This is on your library resource. Now, if you plot the methane data and the temperature trend for that same record, we see a remarkable correlation. So as the carbon dioxide is going up, we see that the temperature is going up. So the temperature tracks carbon dioxide very well. And here we are at present, where the temperature is also tracking carbon dioxide fairly well. How do we know? Sun is not a cause of this change. So here we are looking at from 1950 onwards. We are looking at that global temperature increase. So this is the gray line here. The blue line is the carbon dioxide concentrations. The yellow line is the solar activity here. And this is based on a study by Rahmstorf. And again, the only thing that explains the temperature increase is carbon dioxide. And again, the major source of carbon dioxide right now is humans' use of fossil fuels. This is why we know for sure that the anthropogenic activity is the primary cause of the climate change that we are seeing, and it's not sun and other activities. So what's happening globally? We have covered this in the cryosphere section. This is Arctic ice. This is how many millions of square kilometers of Arctic ice is in September. So when you come to the fall, the Arctic ice melts in the summer, so the September extent is sort of the minimum Arctic sea ice extent. So usually it's always been about 7 and 8 million square kilometers, but since 1995 we see this huge decline in the September ice extent. As you can see, every year that ice is getting thinner and it's covering less of the Arctic Ocean. So by 1996 we hit this low. 2007 was the minimum. As you can see, almost half of the Arctic Ocean was exposed in September. So that's really concerning. One reason is that, as you can see, the ocean is really black, dark. The sea ice is really white. So when the sun is striking here, most of the solar radiation is reflected from the sea ice, but the water, basically the dark bodies absorb radiation. So we have this more warming of the oceans. So that's Arctic sea ice here. Um, so the reason that there's been more warming in the Arctic region is that as the air temperatures increase, we are losing the snow and ice cover, we are losing the sea ice, so we are exposing more vegetation, we're exposing more ocean. So we're decreasing the albedo, meaning that we are decreasing the reflectivity of the surface. So things are becoming more dark, so more radiation is being absorbed, which increases the temperature. So this is called a feedback, so sort of a vicious cycle that basically uh, increases amplifies the temperature change in this Arctic region. So there are various feedbacks around the globe here. Another cycle here is something called the thermohaline circulation. So as the air temperature increases, we're melting more snow and ice here. We're dumping more fresh water here in this Arctic Ocean here. So things are getting more fresh instead of saline. That changes the ocean convection, and that also can change uh, this transport of warm water from the Gulf Stream up into this region. And as you can see, land ice is also changing. We've talked about this briefly in our cryosphere section. Antarctica and Greenland are both losing ice loss, so they're losing their mass of ice. This is in changes in gigatons per year, so 125 gigatons. So it's a huge amount. As I keep saying, 1 gigaton is just a massive, about 400,000 swimming pools of ice. So vast amounts is losing. Greenland is actually losing more ice. So all of this makes it way to the ocean that can change the ocean circulation and the ocean dynamics and salinity. And at the same time, this is also contributing to sea level rise, right? So we talked about that as well. And here we are, increasing sea level rise since 1870. Ground data, this is measured by buoys in the ocean. As you can see, sea level has been increasing about 3.4 millimeters per year. But certainly it is increasing at an increasing rate. This trend is getting upward and upward. Now, another thing that's changing is also extreme events. This is showing precipitation anomalies, so how extreme uh, rainfalls have been from the average. This is globally, and you can see this. The higher the bars, there are more extreme either precipitation or extreme drought. So we see that there's been much more extreme uh, bars here, either in case. So anomalies have been changing. If you look at the significant climate anomalies and events in 2016, this kind of figure here sums up some of the major events that have occurred throughout the world. 2016 for Alaska was the warmest year since 1925. So again, we see that more and more extreme weather records and climate events have been breaking, more recently. As I said, uh, the main culprit is the use of global fossil carbon emissions. So here we are, the total carbon emissions from fossil fuels. As you can see, this shape here parallels and mimics the shape of the carbon dioxide, and as well as the temperature change. And again, we have to keep in mind that there's a disproportionate emissions by different countries. So U.S., this is a figure that says that if we were to allocate all of the temperature change we have seen, which countries and which region would be contributing the most. So U.S., certainly we play a huge role in terms of contributing to the global climate change, global temperature increase, along with a lot of the developed countries. You can see disproportionate, Africa, the whole continent of Africa is very small footprint in terms of uh, their contribution to global climate change through emissions. So again, this is something to keep in mind as well. One major impact that we see is also coral bleaching. You might have heard of this in the recent news. It has been occurring in the Great Barrier Reef as well. So here's the before and after sort of image where when the coral bleaches, you're left with this sort of whitish, uh, when the algae leaves because of warming and more acidification of the oceans, you're left with this really kind of ugly looking corals. And we've had some major coral bleaching events globally. In 1990, there was the first global event. 2010 and 2015, we've had another major one. So as I said, in Australia, this has really plagued the Great Barrier Reef. Almost 93% of all of the corals were bleached in 2015. And again, this is important for a place like Australia, where a major amount of tourism is dependent on sort of this reef tourism. So again, the main reason is that there's more carbon dioxide that's sort of dissolved in the ocean because there's more present in the atmosphere. Basically, you form this carbonic acid, so the water starts becoming more acidic over time, and then the algae that's sort of tied to the corals, they start leaving when the temperatures become warmer, and then the water becomes more acidic. Wildfires is another one. We see more and more wildfires across the country, particularly in the US. We've seen huge increase in wildfires. So this is 2015. We had a significant amount of wildfires in the US. The yellow bars indicate the average number of wildfires. Usually in August, things start burning at its peak, and we see in 2015 everything was burning, particularly in the Pacific Northwest, California, and Alaska. This shows some of the major fires that hit Alaska in 2015. So again, to sum up, there's major consequences of global climate change. We covered sea level rise, extreme events, declining Arctic sea ice. We have talked about global retreat, shrinking ice sheets in Greenland and Antarctica. We talked about ocean acidification, that and warming of the oceans that also impacts the corals, right? So again, major impacts globally as a result of this increasing temperature as a result of this carbon dioxide. So hopefully that sums up a brief lecture on global climate change.